Okay, continuing on with our lectures in A&P, we're going to talk about water in the body over a couple of lectures here. This normally falls right after blood, but I stuck immunity in there just because I thought it was relevant to what we're talking about. So we've already talked about that there's a certain amount of water in the body. We've, I think, seen this before. I didn't really talk too much about it. But we're putting the water in 4 different categories here. And this would be accurate for a calf, not for a cow. So we're looking down here, cow. So we think about the extracellular water or intracellular water. This is water inside the cell. You're looking at 45% of the body weight. So if we look at extracellular water, that's 25. We add those two together. 70% of the body weight is associated with water. We can take the extracellular and divide it into 3 different categories. The interstitial fluid, that's the outside the cells, outside the blood, in the tissues, so between the cells. Blood plasma, 6%. That's the water in our blood. The transcellular fluid is those fluids that are in our secretory glands and waiting to be excreted. So we think about the pancreas, we think about the salivary glands, maybe parts of the reproductive tract that all have water that's outside the body waiting to be pushed on. So if we think about this from a percentage of the total body water, almost 2/3 is found inside the cells, 40% of body weight, 65% of the total body water, and then we can break down the remainder there. You've got your definitions over here. Extracellular water found in the interstitium, the fluid bathing the cells. Less than 10% is in the blood plasma. Transcellular secretions present at any time in the ducts and fluids such as urine are inside our skin. Take a look at the body water pools of a cow. So we said they're a little different. We're going to have our intracellular fluid, just like before, 65% of the total body water, about 45, 46% of her live weight is water. With our cow, we're going to have a significant amount in our gastrointestinal tract, and that's largely because of the rumen, but you also have a fairly large small intestine, large intestine, cecum in the back. That's going to represent 20% of the total body water or 14% of her live weight. So there's a lot of, almost 10% of the weight, her live weight is it water in the rumen. So you've got a significant weight there. That's what we talk about shrunk weight. Stop feeding, stop watering. So we're not paying on a live weight basis for rumen contents. We're paying for beef there. We're going to move over here to plasma. We talked about 7%. We'll say 8% of the body water, 6% of her body weight, somewhere in between there, 7 roughly. So we've got other extracellular fluid representing 7% of the total body water, about 5% of our total body weight. So water is 70% of her body weight, and this is where those breakdowns are. So again, almost half the body weight is intracellular fluid. A significant amount is in the GI tract. So something to consider, something to think about, how much water is in each pool, assuming that you've got a 1,500-pound cow. How many pounds do you have in each of these 4 pools? How many gallons? And you assume that water is 8 pounds per gallon. So you want to go through and do the math, you can work on that. The same thing for a pre-weaned calf. We talked about those numbers up front. We're aggregating them a little bit differently here. Intracellular, gastrointestinal plasma, and other extracellular. We broke that down in the previous slide. You're looking at 45% of your body weight again are inside the cells. Much lower percentage in a calf. Pre-weaned, the rumen is not developed yet, so there's not going to be very much water in there. The abomasum reticulum need to be built up bigger. Similar percentage for plasma, and then you've got a significant amount in the other extracellular fluid. Again, how much water is in each pool in a 100-pound cow? How many gallons? So try to work through that. Give that some thought. It help you visualize, help you understand exactly how much is there. But if you're looking at 100-pound calf, 70-pound water total, that's what 8 3/4 gallons, 70 pounds of that 100. With the water, we have to think about also electrolytes. Electrolytes help bring everything to isotonic. And the two important things we need to think about with electrolytes is they are involved in charge balance. You need the positives to equal the negatives, and osmotic balance. You need the same concentration of particles throughout the body with certain exceptions. So if we think about where the electrolytes are, they are in these water pools moving through. So we have an intracellular and an extracellular. So where are they? If we look at just mammalian skeletal muscle, we look at the intracellular, we have most of potassium inside the cells there, and then we have most of our sodium outside the cells. So you have a pump that's going to pump sodium into the cell and potassium into the cell, sodium outside the cell, set up this differential, and that becomes important in things like nerve transmission and electrical potential across cell walls and things like that. But if you look at it, we've got positives here, 162, 150, and then intracellular, we have to balance our positives with our negatives. And you look here, you've got 162. Most of our negative charges are coming from our amino acids that are acidic. They give up their proton and they leave a negative charge there. So these are equal in water. Their osmotic activity with the milli equivalents in there. So you've got the negative charges add up to the positive charges on the inside. Primary intracellular anion, anion is negatively charged particle, is protein. If we go to the extracellular fluid, as we said, the primary cation on the inside or outside is sodium, and that is going to be balanced with the anion chloride. And again, you're going to have about the same 150 of each of these. If you add them together, you'll notice that they go up to 300 more or less, and that gives us our isotonic concentrations. This is a little bit higher here, and that's a function of a little bit more protein and things like that. But you're looking at, if you add these up, you're getting into that 300 range of isotonic solutions. So we have to balance the positive and the negative charges. So these two versus these three, these two versus these three, and then the total amounts we need to add up to something that's close. Presenting that information visually, you can see that on the inside of the cell, we're dominated by the positively charged cation potassium and the negatively charged protein amino acids. On the outside, we've got the positive cation of sodium, the negative anion of chloride. We have uh, bicarb adding to the mix. And again, if you look at the numbers down here, if you add this up, 1, 2, 3, 1, 2, 3, 4, 5, you're going to get something around 300, something around 300. So charge balances, we have the same number of positive charges as negative charges on both sides of the um, cell membrane. And we have the osmotic isotonic sum as well. When we think about electrolytes and where you find them in a cow, we've already talked about the intracellular, what you're going to find there. Plasma is pretty much the extracellular we talked about. The one odd one you're going to find out, you got 30 gallons of fluid in the rumen, is you're going to find the electrolytes kind of similar to plasma from a sodium perspective. There's going to be an enrichment of potassium. So these are associated with the buffers that come down. The negative charge is going to be dominated by bicarb coming down from the salivary glands, and you're going to have very little negative chloride balancing that out. So again, you're looking at, in these cases, the positives and negatives, if you add the protein in there, are balanced out, and you're looking at something that's more or less isotonic. So if we think about the osmolality in cows, we add the protein in. Intracellular is mostly electrolytes and protein. Same with plasma. We're in that tightly regulated isotonic area, and we have the definitive what's on the inside, what's on the outside of the cell. So extracellular plasma, intracellular inside. We have, with the rumen fluid, we have a much more variable range. These are controlled fairly tightly. This range is quite wide moving through. You're going to have the VFA, the volatile fatty acids that are produced in the rumen, are a significant contributor to the range and variability of the osmolality of the ruminal solution. These are produced by bacteria. They really don't care about isotonic and things like that. They are designed to resist a wide range of things, so they produce the VFA at will. And then we have the balance of the sodium, bicarb, potassium, chloride are going to make up all the osmotically active particles in the rumen. And they're going to give us a range here because these are not nearly tightly controlled as these are inside the body.